Welcome to our lecture in Architectural Conservation and Liturgical Arts. Our topic to discuss is recording historic structures. The lecture will be based on the guidelines developed by HABS, or the Historic American Building Survey. This is a document which I am following in my own practice in documenting heritage structures. So we start off with an excerpt from the Venice Charter in 1964. It says, in all works of preservation, restoration, or excavation, there should always be precise documentation in the form of analytical and critical reports, illustrated with drawings and photographs. Every stage of the work of clearing, consolidation, rearrangement, and integration, as well as technical and formal features identified during the course of the work, should be included. This record should be placed in the archives of the public institution and made available to research workers. It is recommended that the report should be published. Okay, so we need to break this down to explain this. So first, in all works of preservation, restoration, or excavation, there should always be a precise documentation. This means that the documentation is applicable in different types of conservation projects, be it preservation or restoration or excavation or any other types of, which may not be mentioned here, including adaptive reuse or reconstruction. And next is that the documentation in the form of analytical and critical reports, illustrated with drawings and photographs. So in the Philippines, so far in my practice, I was able to encounter at least 4 types of reports that that I have been using also. One is the historical structures report. This is just a documentation of the building itself, of the structure itself, and does not include an analysis of the cultural significance of the structure. Although it could contain recommendations on how the interventions can be done. The next is the conservation management plan, which is a more comprehensive document because it includes the HSR as well as the uh, analysis of the cultural significance, and the recommendations for the intervention can be more detailed. Um, Another document which is new to me so far is the interpretation of the heritage resource. Um, this talks about how the stakeholders would want to convey the cultural significance or to communicate the cultural significance to the rest of the public. And the last one is the DES, or the Detailed Engineering Studies. So this actually is like an as-built plan in the form of a construction document. Okay. Next is that every stage of the work of clearing, consolidation, rearrangement, and integration, as well as technical and formal features identified during the course of the work, should be included. So for each project, documentation should include also each step or processes in that project. Okay, which means it should include the steps, not only the how the measurements and also the appearance of the heritage structure or resource, but also how it should be repaired or how it should be reconstructed. So what are acceptable and what is not acceptable. This record should be placed in the archives of a public institution and made available to research workers. Now, this is something that we do not have yet. We do not have a public repository or a main repository for all these documents. Okay, so it's always project-based. For example, in certain project, you after finishing the project, okay, a copy would be maintained by the one who made the report, and then another one is given to probably the financial institution who provided the grant, and finally the main owner of the property. But sometimes, in my experience, uh, like in the Maribohok Church, okay, when we started, I had to, since I knew that there was a CMP made, so I requested for it. But then even the national agency had to look for it, and as well as the parish was still looking for the copy. And we're actually already starting um, the uh, conservation process. So I mean the reconstruction process. So it was a surprise that at that point they were still looking for the main guide, no, the main reference for the conservation work. And finally, it's recommended that the report should be published. Again, this is something that is not yet established in the Philippines. The reports are most of the time not published as a research or even published as a book. Okay, so it's like the idea is still scattered. So, for example, in my case, I follow certain standards, and another practitioner might be using different standards. Why record and document? So I think this is self-explanatory because it helps in the preparation of a conservation plan by facilitating initial studies, planning, management, maintenance, and monitoring. And because it provides an archival resource, which is an insurance against change or loss of resources and invaluable data for reference, study, and posterity. So even if there is no modifications involved, no need to repair, it is there for posterity. There are three levels in terms of recording. First is reconnaissance, second is the making of preliminary drawings, and finally the detailed record. So the reconnaissance is, of course, when you are still trying to get initial ideas about the project. So you go there and you spend only a few days or maybe even only a few hours to take pictures, make sketches, and some notes, take some notes. Enough for you to make a plan and probably to make a proposal on how to go about uh, the rest of the process, and of course to make the budget and to look for people who can be involved, and hopefully also to get funding. The preliminary is more like the what most people are doing because the records are the output is mainly for reports, either to be published or simply to be submitted. The drawings made are not too detailed because they are for mere illustrations in the reports or in the book. Unlike the detailed record where everything is really very technical and the output looks like it's similar to a construction drawing already. So therefore, the cost would be more in the detailed records compared to the other two, especially for reconnaissance, which cost only a little. So in project preparation, there are these steps that must be followed. First is that we define the scope of work, and then after having done that, agreed on the scope of work with the client, then you can determine the number of personnel that you will need and the skills that are also needed. For example, if you need a photographer, if you need someone who can make use of this instrument. For example, at one point we had to get someone to operate a drone because it is new to us. We do not know how to operate one. And then, of course, kinds of equipment that will be needed. I mentioned the drone as one. You have a transit, and later on we will discuss the other types of equipment actually that we will be using in documentation. And finally, the financial resources required to finish the job. So the budget um, that should include everything because we may need it to get funding for a grant, or if there is already a funding agency, they will be asking for it. Now, in making budgets, um, consideration should be made not only during the measuring period where you go to the site, but after the site when you're already making the drawings. So in this case, the drawings are done initially and um, finally in ink. But then nowadays, we do not do this. We Nowadays we actually make use of AutoCAD. So after measuring, so we go back to our labs and try to draw everything in AutoCAD. Um, so that portion of the work should still be included in the budget because um, during that time, you may still need some volunteers or some interns to do the CAD drawings, and it may take them some time. Of course, you have to provide them with refreshments or meals, depending on how long it will take to translate everything into CAD drawings. And then there's also the possibility of an honorarium for each one. So there is still a cost involved, and many times this is neglected. So that's why, um, well, in terms of experience before, uh, well, many times this is neglected. So which is not very good. So when we go to document uh, for a project, a we should be aware of the hazards involved because there are many possible hazards that we can encounter. The design, construction, or site characteristics, for example. The structure can be built near a cliff, so it's dangerous. It could be very near a road or uh, near a sea, or I don't know, maybe in an island, then you have to cross the sea and it can be turbulent. For example, the location might be Batanes, an island somewhere up north of the Philippines, which is visited by most of the storms. So it's a rough uh, trip going there and back. No? In fact, you can. There's a big chance that you will be stranded there because most of the time the trips coming back are delayed or because of the storms. Um, there's damage resulting from abandonment, neglect, accidents, vandalism, and aging. Um, it is possible that since this is a very old structure that we are going to document, it might be dilapidated already to the point of maybe breaking down. In fact, we experienced that in one project in Boroon, where one of our interns, there's a wooden structure beside the church escuela, and then one of our interns went to the roof, the attic, and he stepped on the ceiling. I think he stepped on even the support of the ceiling at that time uh, gave way, so he fell. And it's a good thing that he's okay. Um, Otherwise, that was actually very dangerous. Okay, so after that, so we made sure that we have to bring scaffoldings always, and we should not be walking along the structure itself, but on our own scaffolding, so more secure support. There are also hazard in terms of social and communication problems. Communication, if you cannot ask for help because there's no signal, or or there's also the problem with some people within the site um, who might be rude, no, or hostile to the team or to you. This happened one time when we were documenting over the weekend because um, it was in the middle of the semester, and the ones helping out are students, and we all have classes during weekdays. So we have to document during Saturdays and Sundays, but the one entrusted to our care does not want to work on a Sunday, maybe because they're not paid for the work. So all the time he was really very hostile to us. and then so we have to really pay extra effort to to work well with the person. So there's a lot of safety precautions that should be done. First is we have to get permission to inform the people about what you're going to do. This is important because sometimes they expect it from us. No, we just don't go to a school without informing the principal. We just don't go to a barangay without informing the captain because they might wonder what are we doing. It's like um, we are trying to overlook their authority, no? They're stepping on their authority and their turf. Also, some of them, most of the time, they're really concerned about what's going on under their barangay, for example, or into school, or for example, in a parish, in their parish, if it's a church. So wear also appropriate clothing. So you will be going to a place where you will definitely get dirty because you might have to go under the structure or above it or in the ceilings, in the attic. In fact, it's better to bring along extra clothes. Use protective gears, the hard hat, for example, gloves if it's necessary. Use appropriate tools. Okay, so this should be identified beforehand and avoid hazardous areas. Okay, think this is really obvious when you go to the site. You have to know where you cannot go, and then so that you have to strategize how to measure those parts which will not be reachable to you because of the hazards involved. And make sure someone knows your whereabouts. That's why it's a good practice to always go by pairs. Okay, so there's always another person who will who can go out to ask for help if something happens to you. These are the tools that are or equipment normally used in transit. If you know how to use them, um, that's very good. I find this really very helpful. Um, of course, I learned how to use the transit when I was in college, but after that, I never really got the chance to use the instrument, so I forgot about how it's going to be used. Besides, I learned how to use an old transit. So the modern ones are more digital and more high tech, so I wouldn't even know how to use them, even if I remember how to use the old ones. So the calipers are for measuring, say, the diameters of pipes, circular objects, and even there's also a wall caliper that can measure walls. So these are big ones. Measuring tape can come in many lengths. In this picture, there's a 3 meter to 8 meter. I used to buy a 10 meter length, but the vinyl type, not the steel type, which is also very helpful. And for even long distances, we have the rolled vinyl type of measuring tape. Uh, then there's the masking tape because we will be marking out information, say along the walls or floors. Then we need to remove them afterwards. The profile comb is really very useful. Okay, and then this is something that you can even buy in online. Um, it can give you the profile simply of the object. You have a say the balusters with all the curve of it doesn't have to be a curve. For example, this path. For example, if you want to know the actual profile, so you just press this comb to that, and then the teeth of the comb adjust to the surface of the object, and so you can trace the profile afterwards. So the level is something that we need to use to determine if our lines are really horizontal or vertical. The measuring rod, I have not used this, but this is like a measuring tape, except that it's like this, it's a rod. Okay. The blue chalk line is your what we call pitik to make lines along a surface. The hammer and stake, I actually have not encountered one, but this could be useful in, for example, in setting the lines along the ground, which we will tackle later. Um, the flashlights, my favorite here, which I find really very helpful, is the headgear, the headlights. You put that because when you go, for example, inside an attic where it's very dark, um, sometimes it's well, most of the time your hands are filled with a clipboard on one and then the pen on the other, so you don't have. It will be difficult to keep on holding a flashlight. Um, and then the torch or the lantern is also very helpful because the one on your head can only see what's in front of you. Okay, but if you want to see all around, especially if you're a group, okay, so it would be better to have the lantern. The plumb bob is supposed to help you um, with horizontal measurements so that horizontal lines, no? I mean vertical lines, I'm sorry. The plumb bob is supposed to help you with vertical lines, making use of gravity. So I think this was discussed in your building tech, also your carpenter square. So if you need to make sure that lines are perpendicular to each other, so we use the carpenter square. In making drawings, the clipboard is really very helpful. In one training I have with Japanese instructors, what they recommended is like a Sintra board cut to the size that can accommodate an A3 paper. And then we put strings on it, which we can hang the Sintra board along our neck so that it stays in our tummy. So that we have a drawing surface there. But otherwise, a clipboard may do if all we need is A4. And then a graphing paper is helpful along with tracing paper. What I normally do is that I already have a graphing paper pasted on my clipboard and then the tracing paper over it. Okay, and then that's where I work because the tracing paper are now available in cut size. Say there are tracing papers A4 size, so you don't need to cut them from rolls. Okay, the others are typical tools we use in drafting classes, the triangles, French curve, even the flexible curve, so that it doesn't smudge. So when your hand goes over your drawing. And then the parallel rule is like your T-square but without the head. Instead, the whole thing, the body is attached to strings on both sides, and that goes up and down those strings. Okay. Um, and this can also be used if you have that Sintra board, like a clipboard that I mentioned earlier. But you have to make your own parallel rule because sometimes they don't sell very small versions. The architect scale normally comes like a Toblerone, your triangular metric scale, but there are also versions which are the fan type, as you can see here in my which you can see in my. So this is another triangular metric scale. So let's discuss about taking field notes. Of course, we use the graphing paper if we to make it easier for us to draw without having to keep on measuring with a ruler, and then the 2H pencil so that it is dark enough without having to be smeared. And what was not mentioned among the tools is the colored pens, which I really find very helpful because actually um, I try to train myself to work using pens alone and no pencils. so that I don't have to keep on erasing. And that also helps me train to avoid committing mistakes. So every line should already be definite. Um, and then I use colored pens, like, for example, the main drawing may be in black, then the dimensions in red, and the notes are in blue, and some others can be in other color like green, orange, or depending on most available colors. Then make sketches readable for future references. Okay, so this is something that I noticed among interns when they make sketches. Normally, you end up making your own shortcuts. Okay, shortcuts are all right. Making your own standards as long as you also note down what you did, so that when you submit the drawing, the one who reads your drawing can understand what you were doing. Example, if you're using symbols or you're using other ways of the dimensions. Um, what is really like frustrating is when the student himself who made the sketch cannot read his own work. So remember that sometimes you need to go to the field to make the measurement, take the measurements, and then it might not be possible to go back, no? Especially if that site is very far away and requires a lot of cost to get there, and then you're under time pressure. Then make separate detailed sketches, okay? Um, in the training that I mentioned, the Japanese instructors were telling us that when we have to make detailed sketches, uh, we can make them along the borders of our drawing. Then we try to fill up the paper as much as possible, and encourage us not to use so many papers, because if you have so many papers, the tendency is that we might lose them. So another practice would be a notebook, with with without lines. So we can put all the details there as long as we don't lose that notebook. Okay. So um, and then we can refer in our main drawings for the details that are located in the notebook. And so when you measure, there's actually two ways of measuring. One is the running dimension. You start out with 0, 0, and then you keep on adding. So for here, it becomes 1 foot and 11 inches. And then there is something like 7 feet added. So this time it's 11. This is 8 foot, 8 feet 11 inches, and then there are again a few feet added. So it's 12. So running. Um, the advantage of running is that you're sure that the overall is the actual, okay? Because if you do the other way, which is incremental dimension, you measure each part separately. Okay, this is 2 inches, that's 1 inch, this is 10 inches, etc. And then you add everything up, and then you will now um, conclude that, okay, so the sum of all of this is the overall dimension. Now, sometimes you make mistakes in the increments, and so your overall might end up a bit short or more. No? So therefore, it's not as reliable. So the running dimension is reliable because aside from giving you the overall, so everything has to fit within that, it also allows you for a check and balance. No? So when you try to add up everything here, um, you'll see that why are they not adding up? No, because there might be some increments that you measure, so you can check. Okay, so we have already established the overall. Okay, so there has to be something wrong along the way. So it's easier to check. So normally what we do is the running dimension for the overall. And then if there are just very small details, we do the incremental dimensions. So since we're not using English system, and I'm not going to encourage you to do that, I encourage you to use the international system, but I encourage you to use millimeter instead of the meter. Why? Because when we use meters, we have to put a dot. Okay, say 3 feet, I mean 3 meters and 20 centimeters. So that's 3.2. Okay, so you have to put that 3.2, and then that dot might get lost. Okay, somewhere. When you photocopy, the dot disappears, or when you wrote the dot, there's no pen, there's no ink that comes out of the pen, and so there's just a very little dot which can later disappear also. So it's very dangerous. That's why the Japanese decided use because uh, to get rid of the dot. No? But then you have to really like familiarize familiarize yourself on the system. So measuring structures, first the floor plan. In the interior of the floor plan, um, you have a you have to show the materials of the floors, the moldings, doors and window frames, door swings, and the structural materials denoted by various poche techniques. Poche is like your hatch, representation of the material. Um, but this actually differs according to culture because in Japan, they always represent doors and windows in the closed position. So it was really strange when I was told about that. But because when we were making our exercise, so our instructors were looking at our work and then pointed to me, hey, I noticed in Philippines they do this. This is open, so with the door swing. And so they told us that okay, in Japan, if you get to work in Japan, it's closed. No? Dashed lines are used to indicate elements above the cut line, such as mantles, arches, or stairs. So basically, the same guidelines in typical drafting. Outside, or this is like inside. No? Um, so you show what type of material there is. If this is a tile, so you can show the design of the tiles. That reminds me about the Maribohok project again, because um, I, I I promised to show you the documentation I made next meeting about the Maribohok Church. Because the tiles, for example, of the church is made up of what we call machuca tiles. So it's like clay tiles with graphic designs, very colorful. The problem with that is that there are so many patterns, or there's so many types of tiles, and then they're formed in a very intricate pattern. And a bigger problem is that a lot of the portions of the churches um, do not show the patterns anymore. Okay. Anyway, the thing here is that we have to base it on the existing, the pattern that we saw. We have to measure them, and then for those that are missing, we have to rely on the drawings, especially the CMP made by San Carlos, and a lot of research in the internet. And so we come up with a floor pattern layout for the tiles. And then so I have to make a design for each tile because we're going to order them. And then I have to count the number of tiles for this pattern, so many number of this, so many number of that. Okay, so it's a tedious work. And then you also have to give the right color, okay, to make sure that okay, uh, it comes out really like the same as before. So exterior, outside of the floor plan that you're making, you should show the roof lines above. If you're in the second floor, you show the porch or skirt roofs of the floor immediately below. Skirt roofs are like the floor, the roof of the first floor element, no, that does not go all the way up. and then basement window wells if you have a basement and you're in the ground floor, and paving stones immediately adjacent to the structure and portions of walkways away from the structure. So you draw a little of what is immediately attached to the structure. So if this is earth or grass or paved or wood deck, etc., etc. Okay, to measure the building, so this is the tricky part. Okay, you have to enclose the building in a box. In a box. This is the I'll start with the most the basic first. Okay, so you make this. This is normally achieved using a string. Okay, so all the points have to be 90 degrees with each other. So it's like laying out for a new construction. So in your building tech, I hope it's was described how you start the layout. No, you put stakes, then you put the lines. But here, these lines become a reference for measuring. So along the lines, you mark out like a ruler. Say this is in feet, I think. So 5 feet, 10 feet, 15. So you put that along the lines, and then from your structure, you make you measure in terms of triangles. Okay. So for example, in this one, oops, let's go back. Um, that corner is so many like millimeters away from the 10 and so many millimeters away from the 15 mark. Okay, so you know already these uh, three sides. Therefore, you can plot out in AutoCAD this point. Okay, so basically that's how we do it. We measure to the nearest marker. Okay, all the edges and all the corners of the structure. Okay, that sounds so easy, no? But it's not really that easy. Uh, I ended up documenting a house in Parian because it was bought by this company. The lot was bought by the company, and then they were supposed to demolish the houses there. And then when they were starting to demolish one of the house, they they discovered that the bottom part of the house is made of coral stones. It was just covered with cement. And then when they got in, they saw that um, the posts were actually like tree trunks. No? So it was really a very old ones. Outside, it looks new because it was like covered with new wood. But when you're inside, you can see no, the flooring is actually made of very broad hardwood, and also the walls. So they asked me to document it before they actually demolish it. But then actually part of the process is actually to determine whether they should not demolish it. So it was my recommendation that they have to follow. In the end, I recommended that they can demolish it, but they have to keep a copy of the report, and then they also need to salvage all the materials that can be salvaged. No? The tree posts, for example, um, there were like 12 of them, very big posts, and then all the boards that they can get, so and all the stones, no, the coral stones. But to measure it, since they've already started demolishing, so it was very difficult to make the initial the polygon, the rectangle, because there were so many debris all around. And as we were measuring, the demolition actually continues. So it was really very nerve-wracking. Um, the engineer was watching us, decided to help engineer the contractor. And he told us that the technique is very good, it's very basic, but I think it would be faster if we use the transit. Okay, so this is why I love the transit so much, except that I don't know how to use it, because that's what they used, following the principles here, and then they finished everything and submitted the drawing to me in CAD file. So imagine that, no? So I was really very happy for him. But otherwise, we could have done it, but at longer time. Um, so imagine yourself trying to get the form of these ruins um, and drawing it, no, in CAD. So that's what they're doing here. They're laying out the main reference line. This is architect Osal, the bald one. One of you actually interviewed him. So you have to know a lot of the techniques in drafting without the use of rulers. So for example, how to make a perpendicular line to a given line without having to measure. So you just make this curve that intersects the given line at 2 points and look for the midpoint and then that D. And so this is actually perpendicular. So that's how you can make sure, for example, how this can be made perpendicular, okay? Or you can use, some people would use a plywood, but that's really very uh, cumbersome. Um, Inside, you can also put a main reference line, like this horizontal here, and then run reference lines which are perpendicular to that in each room. Notice that it has to go through the door. So the fewer, the better. No? And then from all of these lines, the red lines, so you put in markings again, like a ruler, and then make triangulations. Okay. So I hope um, you know how to make use of the Pythagorean theorem. So there's a little math involved. Okay. So with this, you can actually make the measurements inside. Now, do not assume that the walls are always 10 or 100 mm thick, especially the old ones, the old buildings. Okay, um, even if it's an American period building, the walls are even thicker because some walls are not made of coral hollow blocks. They're actually what we call buhos, no? Or reinforced concrete wall, and they can differ depending on where they're located. If they're the main structure, they're thicker. If not, then they're thinner. So I've experienced that many times. No? Um, the bigger problem if you're dealing with Spanish period structures like churches or some um, convents or some houses, because the walls are really very deep. Okay, and then they're made of 2 layers of coral stones, and then there's no standard. So therefore, you have to really figure out how they look. And there can be movements in a building. For example, there's an earthquake which shifted the the whole thing. No? So it's not everything is perpendicular anymore. So you have to do it this way. Yes, the use of transit um, can handle something as complicated as this. Um, I've already emphasized about the use of the transit. Now, if the interior is made up of like a elliptical space, so you can still do that one line here, reference line in the middle, but here in this case, since the doorway, the opening for the doorway is easily known, so um, the what was done here was that uh, there were two reference lines. Of course, they triangulate still. And so all of the edges and corners on this side is measured along this CD, and all of the corners and edges at the bottom side is measured along AD. Now, if you have this type of configuration, so you cannot have one single reference line. So you'll have to triangulate again, no? The corners and use that main triangulation as your reference line. So for example, along what? So along AWZ, you can get all the points for this arc here on the left side, and along X and Y, you can get the uh, reference points for the curve along the right side. Um, it's also possible to just lay out a right angle, a right triangle in the middle, sort of, no? But then you need to make a reference point. In this case, the reference point is letter D, point D along the corner of the house. And then he runs a line DC and makes a perpendicular line AB, perpendicular, a line perpendicular to DC, and made an angle line AF. Okay, so the AFC is now uh, the main reference polygon or triangle. So it's 90 degrees. And so everything along this side, along AF, the curves along that so is measured along AF, and the bottom it's measured along AC, and towards the right is measured along CF. So and so you're able to generate that curve, no, to make that. So very easy, easily said. It can be as complicated as this also, especially in churches. Okay, but you really do need to do a lot of triangulation. Okay, I'll also show you my notes next meeting. We in Dawis, we were asked to prepare the ground floor of the convent to make it into a museum. So after removing everything, we came in and then we have to document. We have to do a lot of triangulation just to get the actual uh, configuration of the interior. So a lot of these things, no, the windows actually go tapers inwards, and then there's another wall, and then there's another hole for the window. So it's complicated. This is not a very good example. I'll show you some better example next meeting. And then when you're measuring elevations, so many things here, no? Field sketches show structures without planting, shades or shadows, glass, utility cables, or screen. So you try to simplify the drawing. So don't use the shades and shadows, never mind the glass. So, as, well, the essentials should be there. Whether you put in the details depend on how much space you have. And then if you don't have much space, so put the details somewhere else. It's a bigger drawing along the side. Gutters and other features that obscure the essential elevations are to be rendered separate as details. Some roof actually covers part of the wall, okay, because they're lower than the end up lower than the wall. So you can actually like cut that off and then put the drawing on the side. So rather than delineate every brick course or row of siding or shingles, count the rows to window openings, rather significant features. So for example, in a window, in actual, there are maybe 12 levels of bricks. So along that window opening, you don't have to draw all those 12. So you just make a few drawings and then just indicate 12 rows, or make like a dimension for the windows, but instead of the dimension, you also include 12 rows of bricks. So at least fewer lines. As in construction drawings, field sketches will refer to details drawn at large scale for clarity. So we mentioned that about making detailed drawings. Porches, screen doors, and window shutters may be drawn separately. In many instances, screen doors, gutters, and non-historical building elements are graphically removed from the final drawing. That is, when it is determined that to draw them would obscure more important features. Now this one, although it's in halves, I actually don't understand it much because we seldom remove important drawings unless they can be details. These are details. So there's also these decorative and structural elements such as finials and column capitals will appear curvilinear in perspective, but are in fact linear in elevation and must be drawn in such. So we also need to have that, so we should be able to analyze also how it would look like in elevation. So for example, this is round in perspective, but actually it's just straight, no? And then it's domical here, so things like that. This is again not a very good example. I, I tried to get this from the book, but it's so pixelated. Okay, so you can have a bay window. This is a drawing of one part with other dimensions, so you can have drawings. So if you do something like this, you also need to have the drawing of the complete building and then indicate which part this is. Now, what if the building is too tall? Say this lighthouse, it's not possible for you to go up to this point, letter C, and measure to B. So what you do is actually you find the center point of the structure and then go far somewhere at 2 points. So you measure this distance to B, and then there's also another distance to A. And then from that point, taking note of your height, eye level, you measure the distance, the angle, okay, of point C. Now, that can be done using a transit, or if you have a laser measure, which can also measure angles. Okay, so actually I was planning to buy one. I used to have that in San Carlos, no? But well, San Carlos has that. Or it is architect Ragas who actually told me that you can also make use of a piece of cardboard where you note your line of sight. You just draw a line of sight towards that, and then you take note of the angle after making the drawing. So it's a very crude way of doing it, but if you don't have anything else to base on, so that's the best that you can use. But the transit is very expensive. That laser, I saw some in Shopee. It can be affordable. It would be a good thing to have. Okay, this is what I mentioned that a house can be deformed by earthquakes or other factors. Okay, that's why it's not good also to assume that all the vertical elements are actually vertical. So especially if it's as obvious as this, but sometimes it's not as obvious, no? Because okay, everything seems to be straight, but they're not really. Okay, especially the floor. The floor is not always straight. Okay, that is one observation I have with all my interns, that when they measure, they always measure, they always neglect to measure to include the floor. So that's why sometimes you don't know whether at one point it's supposed to step down or step up, because sometimes their houses are located in places where there's a lot of modification already. You know, in the kitchen, someone placed a platform or something else, and then and then like in the Maribohok Church, the floor is actually sloping to 60 centimeters from the entrance to the altar. Okay, at that far, it's hardly noticed. Okay, and it's a good thing that the engineers actually made sure the if the floor is actually horizontal or not. So we realize it's not. No? So we have to work on that. Um, we'll go back to that. No, sketching and measuring sections. So sections. Basically, sections are there because we want to show the inside also of the structure. But if but only if the inside is simple, like it's one room, like this structure has only one room. But if you have so many rooms, so you have to make individual elevations, room elevations. Okay, sometimes you can section like this way, because in this case there are two levels. Beyond this door, uh, the floor is beyond this door. There's a part which with a raised floor. Therefore, he sectioned it halfway, to show the front and also what's behind. What is important really in the section is the level differences in levels, horizontal levels. Um, this also assumes that the pattern here is the same as the other side. Okay. Okay. So this one, we encountered this in the convent of the Maribok Church, because what happens is that you have this very big space, but in between the space you have a lot of frames. Okay, and then those frames in this drawing, the wooden frames may differ in terms of design. In my experience in Maribok Church, the ground floor is open, but looking at one side to the next, you have so many levels um, of columns. But then it's okay for the stone columns, but some levels have additional uh, wooden columns, and then the wooden columns differ. Another level, the wooden columns are dressed. In some other level, the wooden columns show the like tree trunk, no, which is not dressed. And then there are braces, and then the braces are not consistent. Some have very big braces, some have small one. So each level is different. So what you do is you actually make a drawing of each level. So it's like you make a section of the letter C. What can you find in letter C? What you can find in letter B and A, without drawing what is beyond. Okay, only what is within this plane, plane C, plane B, and plane A. Okay, so that you actually have a lot of sections. Um, this example is, this is supposed to be an example for that, but it's not a very good example because he showed uh, the last wall at the back. So maybe because this is the last frame also. Okay, but otherwise you do not need to show the last wall with the windows. Your focus is only along that plane, with the frames, with the framings. So domes are very um, tricky. It says here the curvature of a dome may be plotted by first stringing a tape across the diameter of the drum supporting the dome. Then a plumb bob is then suspended from various points along the dome ceiling down to incremental points along the tape. So this assumes that you have scaffoldings and that you can actually reach the ceiling of the dome so that you can pick a point and then drop a plumb bob. Okay. Now the length of the string is recorded each time. The distance from tape to ceiling at 90 degrees to the horizontal tape will provide points along which the curve can be plotted. As in all hand measuring operations, attention to safety is especially critical in measuring high interior spaces. So this next one can be best described here. So well, this is like a mansard roof. Okay, so you have these points here. You drop them. You have this ceiling, this tape here, which is your main reference. Okay, so you measure. So imagine this to be a dome. Okay, I wanted to make a drawing earlier, but it's so complicated uh, doing that in computer. So anyway, imagine there's a dome and then you pick points along the dome. And then this line, the horizontal line, is along the spring. Uh, how was that described? Um, well, across the diameter of the drum. So the spring line. So this is the spring line where the dome starts. Okay, so that's how you measure it. So which means if you are going to measure something like a big church, an old church, uh, and even the modern church are also a bit high. So you need to put up scaffoldings. You need to climb the scaffoldings. Okay, so you need to really make use of the uh, safety equipment. Sketching and measuring details. It says here, detailed sketches must be drawn large. So all in caps, large. Um, at some point, it is better to draw 1:1 in scale. Okay. When we are making the um, we were reconstructing the retablo of the Maribok Church, I often find myself producing 1:1 patterns. Okay, because some parts are missing, and then I have to copy the other parts if they're the same, and then to copy it 1:1, no? And sometimes even draw it in computer in CAD and print it out so that they have something to follow when they cut it and then they make the carvings, etc. So those details. Maximum use of artistic talent is encouraged. Okay, that's why the architects are the best persons to work in this type of documentation and heritage, and because although engineers are trained in drafting, they might not have that artistic part, no? Not as much as the architects and everyone else who went through drafting schools in vocational schools may not have that. No? A limited amount of shading and other rendering techniques can enhance field sketches, but team members should use field photographs to produce texture and three-dimensionality. So with the camera, so it's easy um, to capture details. But there are rare instances when even the camera cannot capture the detail, you know, that you always find yourself the need to draw it, okay? The need to draw the perspective or the image, not necessarily in elevation, but in 3D. And then with the shading to really show the form, okay? Probably because camera is limited to the amount of light available. So if it's too bright or too dark, so the image might not be too clear, you know, the form of the building or the details not too clear. Shining a flashlight down on the element will produce crisp shading lines suitable for later drawings. What does that mean? Okay, so if you do not have enough shadows, so you use a flashlight to create some shadows to reveal the form. Okay, so just to reveal the form, because otherwise, I mentioned to you about the too much light, and all you can see is white. You cannot appreciate the form, okay, where it curves, etc., etc. So so it's a study in shades and shadows. So profile gauges or the profile comb that I showed you earlier, tracings and pencil rubbings can produce fairly accurate representation of moldings, tiles, ornament, cast iron, or stone structure. If possible, compensate for paint layers that tend to obscure the sharpness of details. Okay, because sometimes there are very small carvings, but then they paint over it, and for so many centuries and so many layers of paint, you can imagine that those details are no longer there because you can now see just a lot of paint and like it's covered with paint, so it's like you see less details. So sometimes it's necessary to peel off the paint just to reveal the detail. But you don't peel off for all, no? It's only some, only portions because normally the details would repeat. The supplemented with photographs and measurements, these artistic techniques can be used to produce striking ink drawings. And these techniques must be implemented with caution in order to avoid damaging historic fabric. Okay. So what they're doing here is that they're trying to trace the bas-relief in Santo Niño Basilica, so that they can record it, transfer it to CAD. Okay, so they use a grid system. So they have a plastic sheet they put on the lines, and then they put that plastic sheet on the bas-relief, and then they start tracing. So what can be easier? No? But again, you have to be artistic, no, to know which part here should be traced, because you actually have, say, the robe of a saint here, and there are parts which are concave and convex. So you only copy supposedly the whatever touches the um, whatever touches the plastic. But then at some point, you also need to, when there's an edge, for example, the edge of the robe, so it does not touch the plastic, but you have to trace it still. Okay, but you have to know how to trace it when that's far away from the plastic. Okay, so you have to be imaginative, and this is what I did also in the retablo that we mentioned. So these guys are now architects, and this guy here with the on red is now married to an architect also. And both incremental and running dimensions may be used to measure small objects, but incremental dimensions should only be used if the shape of the object prevents running measurement. So we mentioned that earlier. The datum point should also be selected for convenience and not necessarily placed at one end. So the datum point can be somewhere in the middle, okay, but okay, always uh, indicate where it is. So it says here, if you'll note, it may be useful to indicate the beginning of a line of running dimensions with an arrow. Okay, so this is where your other pen would, uh, other colored pen would be useful, assuming all your dimensions are red. So to make sure that this arrow is same, you use color green maybe. Okay. Um, so calipers are useful, but I think on this slide, what is emphasized is the emphasis. Now, in your history one, you should be able to, you should have encountered the word emphasis, especially when you talk about the Greek and Roman buildings, because they make the columns with a certain bulge, you know, to cover uh, for the optical illusion, because our eyes actually uh, tend to bend straight lines. Okay, so if it is straight, when we look at it from the bottom, our eyes would bend it inwards. So it now looks like it's like this, no? So therefore, they designed the actual columns to do bulging, so that when we look at it from the bottom, it looks straight. So again, never assume that vertical elements are always straight. So in this case, there's an emphasis involved. So you have to take note of that. Measuring roof, again, it's all triangulation and looking for a particular reference point. So what you do with the dome, well, inside the dome, you only have one horizontal, but outside you need to to use vertical reference lines. And then sometimes you may need to use two, one on the top, one at the ear, and you might end up actually using more along if the dome is really very big, in which case you have to come up with a system, okay, following these principles. Preliminary drawing, let's skip that. No? So the scale is the same as the uh, standards in drafting. Most of the drawings are 1:50. And then you'll have some details going 120 and going even as big as 1:2. But then sketch plans can be 1:100 sites. One is 200 to 1000 and smaller for um, maps. Landscape documentation. So you might end up documenting not one building, but some buildings in a property to locate them for how they to locate them, no, from each other, even trees. No? So you use triangulation again. So corners to corners, triangulate, corners here, triangulate. And a tree trunk, consider it one point and then triangulate it with the corners. Okay. So what makes this difficult is that they're normally far from each other, and then so you need to use the vinyl type of measuring tape, and then you have to make sure it's taut. Okay, if you don't have that, then you'll have to run a string, and then you measure the string later on. Recording pre-existing conditions. So assuming that we have already a drawing of the existing, that is now our base drawing. So we make another series of drawing, um, and then we indicate in that other drawing. So we make a copy of the elevation, for example, and then we make a drawing that shows the conditions of the walls. Okay, now the condition of the walls can vary in different places. In some places, it can be intact. In some places, it can be peeling off. Then some places there can be a lot of vandalisms or vegetation, etc. Therefore, you have to make your own like crochet, no, or hatch design, as you would call it. Um, and then so indicate that in the drawing. Now, in this drawing, for example, uh, what is shown is not the condition, but then the age of the wall. So this is, or maybe the interventions. No, in 12th century, there's a heightening there, and there's a refacing in the 14th century along this part, and then this part is obscured by modern rendering. So this is church. This is actually done by a fourth-year student, um, but I forgot what church this is. So he made his own legend and then applied it here. So therefore, when you do your work, okay, so you know what to do in these portions only. Okay, so this is also by a former student. They're now architects, all of them. So this one is in the Laget. So we call that morphology. And then the study of doing this is like sometimes called in international parlance as building forensics, no? CSI. So building forensics, and it actually helps. One look, you can see, you can check, no, what's happened. This is done by Escuela Taller for the one in, I forgot. But there's a church that they were trying to, in Manila, that they were trying to, they already finished, I think. Um, so you can use different colors, and then you have here the legends. So there should always be the legends, okay? Because it's like your own improvisation. There's no standard way of doing it. You can improvise as much as you want, but then the standard way of doing it is actually just to provide a legend. So if you don't provide the legend, this is a totally useless drawing. Okay, totally useless. So we're at the end. It says here, as heritage recorders, we should be able to discern the character and values of our cultural properties in order to document them properly. So one criteria to become a heritage recorder is that you have this background, you have appreciation of history, okay? Because otherwise you just be, you'll end up actually recording this and then assuming so many things, assuming that all the vertical elements are really straight, 90 degrees with the ground. You'll assume that all the walls are all this size, this thickness. You'll assume everything is like modern. Okay, so there's a lot of assumption, and then that's not the correct way, because there's a lot of imperfections, especially in the old buildings. I do have a few more slides that I want to show. So this is just something that I saw in the internet. No? So you make legends, and then, but then I promise to show you more information, more samples next meeting based on my projects. Okay, so those are everything. That's a lot, no? I learned that I think Architect Solis had Mr. Fung Yu give her class a talk about recording, but anyway, I can assure you that I have the same extensive and even I think more extensive experience than Mr. Yu. So you're not being shortchanged here. No? Also, we will learn more about all of this. So I'm presenting to you more of the principles, and I'll show you examples next meeting, how I try to apply them, or how my friends try to apply them in their projects, and then point out some mistakes. Of course, even I make mistakes, no? Or some other things, no, that are helpful to understand this more. And next meeting also, we will tackle about photo documentation and basically photo documentation. I'm supposed to include video documentation, but I don't have experience in video documentation. I'll try to see if I can find some resources or resource persons who can also share. But those are the topics for next meeting. Okay, before we end, I'd like for us to finalize these research topics and groupings. Okay. First, I'd like to call on the names on blue with the blue color, because these are the ones without a group, and I want to know which group you are in. And then next, let's go over all the topic, whether they're still the same topics, and especially those who have no topics here. So what are your topics? Okay. Let's see. Wait. Is Jacqueline Abala here? Hello, Jacqueline, are you here? You're here. But what group do you finally belong? You can type it in the chat box. Okay, so calling Jacqueline Abala, Hannah Jane Omo, Trisha Tan, Elijah Garay, and Dexter Tenefrancha, please type on the chat box where you now belong, which group, who are your companions, and then the rest also type in the chat box if the topic here, the title is not the same anymore. So please type the new topic. For example, I think the ones of Romero and Manghihilot was changed. So I now made this change. Before it was not this one. So also Alcuitas, Centilio, Coriba, Comendador, Sandot. So what are your topics? No? The Buet, the Kitpekit, and Pineda. What are your topics? Please type them all in the chat box so that I can make the changes. And then some of you actually sent me an email about your questionnaires, and I have not responded. There was one by Garcia. No, I promised to respond the following day, but until now I have not been able to respond yet. I'll do that tonight. Uh, I'm sorry, I just got busy, sidetracked. Uh, and yeah, so and I also need to finalize this so that I can coordinate again with Architect Malayaw. And I need to meet with him about what's next. But I promised you that I'll send my comments on the submitted questionnaires that I received. So that. Um, okay, so there are now a few who have Dexter and Hannah has commented where they belong, and then Aurora, Tabuet, Oncines, and Comendador has made commented on the topic. Then the rest, since we are ending, I don't want to wait for the rest to wake up, and then so please just send me an email. No? Some of you are actually trying to already are contacting me through Messenger, so I don't mind. You can also look for me in Facebook and easy to find. Okay, so for now, it's very tiring. So let's end. Let's have a break. Um, so thank you for coming and see you next week. Okay. Uh, I'll just turn off the recording. By the way, I'm planning to fill up the missing parts in the recording and then put them all together uh, before I upload this in YouTube and Canvas.